So I'll sign those as you bring them to me. I want to get into at least talking about, there's two questions on here I want to get to with side-side angle, okay? Remember when we talk about side-side angle, this is the ambiguous case, okay? And the idea is if I were to give you guys components, two side lengths, let's phrase this. Let's say I give you two angles and a side. Two angles and a side, and I tell you put them together in angle, side orientation. Okay, if I give every one of you the same two angles and the same side length, every one of you is going to make the exact same triangle. Does that make sense? Okay, so that idea means then that when we go through the work algebraically, we should have one and only one answer for the missing parts. Okay, if I were to give you them and told you to put them in angle, side, angle orientation, same thing happens. You get one and only one triangle, therefore in the algebra we get one and only one result. But if I gave you all an angle and two sides, and I told you they had to be in the order of angle, side, side, okay? Depending on the sizes that I give you, we may all not be able to create a triangle. We may have no triangles being able to be made, okay? Just depending on the sizes of the angle and the side lengths that I give you, okay? If I give you angle, side, side, depending on the side lengths and angles, we might all create the exact same triangle. There might be only one triangle that could be made. Okay? If we do it a third time, the same components, angle, side, side, I'd say everybody make a triangle, we could potentially in this class have two completely different triangles being made, but both being valid. Does that make sense? Okay. That's the ambiguous case. We don't know, based off the initial conditions, whether we should have 0, 1, or 2 triangles existing from that information. Okay. And there are other ways of deciphering 0, 1, or 2. We could maybe do some preliminary work to find 0, 1, or 2 right off the bat. But those preliminary ways are more involved and more complex, I think, than the technique that we're going to use to decipher whether we have 0 solutions, 1 solution, or 2 solutions, okay? If you have 0 solutions, your calculator will tell you that. Your calculator will tell you undefined the initial time that you type something in, okay? And we'll see an example of that towards the end. But this one here, we've got angle, side, side. We got these components here, okay? And what you're going to do is you're going to set up your law of sines. Okay, it's angle, side, side. I always put that on my problems. Every problem I come across, I'm going to look at the parts that they give me in the order that they give me, and I usually don't write them down unless it's, I don't write this down unless it's angle, side, side, or side, side, angle, okay? And I just write that down because it's going to remind me that there's extra steps involved, all right? So the first thing you're going to do, you're going to write down your ratios. Okay, and remember our ratios are linked by angle, sine of the angle, over the side opposite. So I'm going to say sine of 45 over 7 radical 2. Okay. Now, as I work through the rest of the triangle, those two things are opposite. Okay, now do I know the angle? Do I know B's measurement? No. So that is, and it's different than the example we saw 2 days ago. Every example we saw with angle, side, angle, or angle, angle, side, the first thing you're finding is a distance. If it's angle, side, side, the first thing you'll actually be finding is an angle measurement. Okay. And then 7 here. And if I wanted to go further with my relationships, we would say sine of angle C over side C. But my hope is that you recognize in order to solve for something, I have to use those two, right? Okay. So we're going to go about solving this just like we would any other trigonometric equation so far. We're going to cross proportion we've dealt with. We're going to cross multiply. Get 7 sine of 45 equals 7 radical 2 sine of b. Okay. Now, sine of b is the variable component here. So you're going to try to isolate that thing. So if I'm going to isolate that, what do I need to do? Divide by 7 radical 2. And that's going to give me sine of b equals, will these 7's cancel out? I get that, right? Okay. Now we could do some side work here. Does anybody remember, and we can grab our calculator here in a moment and type it in directly as well. Does anybody remember what sine of 45 is? Sine of 45 is actually radical 2 or 2. If I put that over radical 2, I'll get sine of b. Does anybody know what radical 2 over 2 divided by radical 2 is? 1/2. So you get 1/2 equals sine of b. Does anybody remember the angle b that generates a comparison of opposite divided by hypotenuse of 1 over 2? Sine of 1/2 is 30. Okay. Now, that is something, like I said, hopefully after chapter 6, is something that we prefer to do rather than what we're going to do here. What we're going to do here is, once we got to this step, how do I get that b out of the argument here? Sine inverse. I'll take sine inverse of this side. I'll take sine inverse of this side. That's going to drop b out on the right-hand side. So erase that and write b. And now all I got to do in my calculator is type this thing in. All right. Just go to my calculator. Sine inverse of sine of 45 over square root of 2. Make sure you're in the right mode. I am. And you see that it spits back to 30, right? Okay. So angle B could be 30 degrees. And just be aware that I said could be 30 degrees. Because we had to decide, could it be something else? Okay? So once you find that first angle, okay? Once I find that first angle through the, when I have an angle side-side scenario, I'm going to see what is the supplement of angle B. And what would the supplement of angle B be here? 150. Come back up to my picture. Can that angle right there, based on the other information that's already provided in the initial conditions, can angle B be allowed to be 150 degrees? No. Okay? So, because of that, we're not going to have two answers. We're going to have one answer, and it's going to be this triangle that has a 45-degree angle, a 30-degree angle, and how big would this angle here be? 105. Okay? Now, the reason for that, let's go back to what I showed you the other day. Okay? If I've got an angle here, we said that angle was, started with 45. This angle here is segment is 7 radical 2. And this segment here, they start us off with being 7, right? Okay. And the demonstration I showed you last week, or it's Monday, was obviously this dotted line is going to be my third segment, right? I just don't know how big it's going to be, okay, until I align that line of sight, essentially, up that imaginary line there with this side here. So I got to rotate this side and had it about right there would be that triangle, correct? Does that make sense to everybody? So then, if I want to find the distance, so we're gonna figure out this in a moment. We should be able to use the law of sines now to find the distance from that point to that point, and we should get something pretty close to 13.52. Does that make sense? Okay. This angle up here would be the 105. Now, here's the thing. Does a second triangle exist? Well, will a second triangle exist? Can I intersect this dotted line? Because remember, that dotted line is defined by the condition that I gave you this cardboard angle cutout right here, right? So we know this dotted line has to extend this direction. Can I take this line here and extend and touch that dotted line again? No. Okay? So we see here, even though it's given that distance, right now, I can't create a second triangle. Okay? And it all has to do with how this number, this 9.9, relates to this altitude right here. Okay? If this, basically what happens, if this 9.9, I believe this is the way it would work, is that if that 9.9 were between these two numbers, between those two numbers, you should be able to get two triangles. If it's greater than this number, you're only going to get one triangle. Okay? If it's less than this number, you're going to get no triangles. And that's what I was saying earlier, that there's preliminary ways or techniques to determine how many solutions you're going to have before you do anything. And it's based off of knowing what this altitude distance is, and that's hard to find. Okay, so the technique that we're going to use here is a little bit easier. So we know that it can't be 150. Okay, so that means there's only that one triangle that can be created. And now if that's the only triangle that can be created, can I go ahead now and find C by taking sine of 45 over 7 radical 2 equals sine of 105 over C? And once I cross multiply all that stuff, I should get C equal to 7 radical 2 sine of 105 all over sine of 45. And once we type that in, 7 square root 2 sine of 105 divided by sine of 45. There's the 13.52 that GeoGebra was giving us. Okay? So it's still, the ambiguity is that at the onset, per the previous, or the initial conditions, we don't know how many solutions there are. We go through the work here, and now we can say, well, there's one solution. We know there's only one. Okay? But even though there's only one solution, it's still called the ambiguous case. Now let's go to the next one. So that's a scenario where we get one solution. Let's look at this one. Okay? Try to set this up like my GeoGebra is. So I think GeoGebra has angle, they call it B, but I'm going to call it, let's actually do this. In your notes, let's just call this angle B right here. Call that B instead of A. So we want this to be, we'll go 43.1. And then we want, let's see here, this here would be 248.6. So I want this to be 186.2. There's A and there's C. It really doesn't matter. It doesn't matter how you draw it. I'm just trying to keep it the same structure as when I go over to the GeoGebra and show you that everything is the bottom left angle here is the bottom left angle there. The 186 is at the top left segment, 248.6 at the top right. But if your picture is rotated, flipped, whatever, compared to mine, as long as 186.2 is across from A, 248.6 is across from B, you're going to get the same results. All right, so here we go. Again, at the onset, I'm going to set up sine of 43.1 over 248.6 equals sine of A over 186.2. It's also equal to sine of C over C, but I don't know either of those things, right? So I kind of ignore that ratio. Is everybody okay with that? That's really the trigonometry. Okay. Now we're gonna work on our algebra. When I cross multiply, we get 248.6 sine of A equals 186.2 sine of 43.1. Sine A then is going to equal 186.2 sine of 43.1 over 248.6. Is everybody okay with that? How do I get this A out? Take the inverse. Okay. So inverse this side. Inverse this side. And you're left with A is equal to that stuff. I don't want to rewrite it again. It's the same exact stuff. Is it okay? All right, so let's type that in, see what we get. Yes. Did I mess that up? All right, so good catch here. So what doesn't matter though. All right. So again, sorry. I'll see if I can edit that out of the video as well. But let's just go back. I'm deeply sorry, but I just wasted your time there on that. Let's just go ahead and keep it this way. We're just going to have to adjust the triangle in the GeoGebra. Shouldn't be a big deal. Basically, you have to visualize a reflection in the GeoGebra. But if I say angle A, 43.1, this would be 186.2, and then B is going to be down here, be 248.6, right? Everybody okay with that? All right. So now, if we set up our law of sines, it's going to be the sine of 43.1 over 186.2. Sine of B over 248.6. The nice thing about this is algebraically, once you understand how to do one of them, they're all the same. And you can start to learn, the more proficient you get, you start to learn shortcuts. A lot of times, eventually I get students that can just jump straight to B, just because they know what's going to happen here with this stuff. But if we go 186.2 sine of B, it's equal to 248.6 sine of 43.1. And then to get B, we're going to inverse this thing. So sine inverse 48.6 sine 43.1. All right. So if we would have kept doing it the way, like when I renamed the angle and everything, it would all work. Okay. But we only get that one triangle. Now I want to demonstrate here that we've got two solutions. Does that make sense? So it would have been just redundant in regards to doing an example like we've already done. But we didn't do anything incorrect in that algebra. But now with this one, so let's go ahead and correct this. So it'd be 248.6 up top, and be the 186.2 on the bottom. All right. So we're getting an angle that could be 65.8188, right? Okay. And that's what I like using Desmos because I can do that. I can now say, well, I'm going to call that angle B. Okay. So here's what we need to do next. Okay. Like I said, once we find that first initial angle, we first ask ourselves, and it will, but can I have angle B to be 65 point, what was it, 8? Can it be 65.8? If I add 43.1 to that, I'm still under 180 degrees. Yes, I can have that. Does that make sense? Okay. So that is a perfectly fine angle to have. Okay. Now the question is, what does it supplement? This is why I like to be able to call that B with Desmos, is because now I can go 180 just minus B, right? And it gives me the supplement. Okay, so the supplement of angle B, okay, you saw there was 114.18, I think is what it turns out to be to 2 decimal places. All right, now my question is that okay? Can I have in the triangle that they provided me with, can this angle right here be 114 degrees? Yeah, because if I add 43 degrees to it, I'm still under 180 degrees, right? So I have about 23 degrees for angle C left over. Is that okay with everybody? So because of that, because when I take the supplement and compare it to the original angle they gave me, and it is sub 180, less than 180 degrees, then you have then two ultimate solutions. So what I'm going to do, once I've made that connection, I'm going to set up basically I'm just going to organize my work. I'm going to say triangle number 1 and triangle number 2. Okay? Triangle number 1, we've already got most of the work for triangle number 1 done. We know that angle B is going to be 65.8. I'm around at 2 decibels, 65.82. We know angle A was already given us 43.1, but now angle C here would be, okay, so we had 43, I'll do it this way, 180 minus 43.1 minus then B. So the remaining angle would be 71.08. 71.08. And that is simply taking this information here, and when I used my calculator initially, this was 65.82 degrees. Then triangle angle sum theorem tells me this one's got to be 71.08. Okay. And now, does that give you enough information to solve here for segment C? Can you now compare that with that, or that with that, and that to that? Does that make sense? So I'm going to write it as, because the 65.82 is rounded, I'm going to try to avoid that number. But I'm going to go sine of 43.1 over 186.2 is now equal to sine of 71.08 over lowercase c. Okay? Now that number right there is also rounded. So if I use that number, I've got to pay attention to how my WebAssign wants the answer. Okay? Does it want me to be, precise to 2 decimal places, 3 decimal places, 4, whatever. If it says answer to the nearest hundredths, then I better not use 71.08. I better go 2 or 3 more decimal places out beyond that to guarantee that my hundredths is not impacted by rounding error. Okay? But if I cross multiply here, I'll get C sine of 43.1 equals 186.2 sine of 71.08, and C 186.2 sine of 71.08 divided by sine of 43.1. So I'll type that stuff in. Okay. Now I'm going to, because I've been using Desmos, I'm going to call this angle C. So I don't have to do any rounding, right? So if I do this in Desmos, what happens is that I actually get a precision out to 9 or 10 decimal places because I use absolutely no rounding. So I go 186.2 sine of C, and we're going to divide that then by sine of 43.1. And that is out to really that 9. I am precise out to that 9 now. So whatever decimal place they ask me, I can be 100% confident in that answer. If I use 71.08 instead, you can just see that the hundredths place is different, right? Okay, because I used a rounded value, so my answer is going to be a little bit inaccurate. And the precision is important as we do these types of things. Does that make sense? Okay. In the past, I just get people, Mr. Fay, I'm always a 10th off or I'm a 100th off or whatever. I think I'm doing everything wrong. It's not. They're doing the intermediate rounding incorrectly. Can we do that? All right, so here's where angle side side is a real pain in the butt. That's why I kind of used that visual for us the other day, is because we've realized now that there's actually a second triangle that could be made. So because there's a second triangle that can be made, we are going to do all this work again with this second triangle information. Now, I'll do it in different color here, but I don't usually try to draw my triangle so that it incorporates an obtuse angle like this. I'm going to say angle A was 43.1. I'm going to draw the exact same triangle here. Angle B, now we said, is it could be 114.18. Okay? And then that would make angle C down here, I believe it's 22.72 degrees if we use the triangle angle sum theorem. This would be 248.6, and this is 186.2. Okay? Again, like I said, I don't care. This should be an obtuse angle. It doesn't look like it, but I don't care because I'm only using the picture to realize what is opposite one another. So I'm going to go sine of 114.18 over 248.6 is equal then to, again, I'm going to try to avoid using rounded values. So I could say that relationship is true. I could say sine of 43.1 over 186.2 is true. And now we have sine of 22.72 over lowercase c over here. Okay. Now, if I write that extended ratio like that, just comparing every angle to every opposite side, which one would be the best to choose and why? The middle one. The middle ratio would be the best one to choose. Why? Not rounded. Okay. I could choose. Obviously, we got to use this one here to find C. And what kind of stinks about that is because this 114.18 was rounded, this 22.72 is rounded. So if I choose that one and that one, I have now compounded my rounding error even greater. Does that make sense? And that would be something, if I want to use those, that's fine. But if you're going to be accurate to the 10th place or 100th place, you would need to make sure that you round this one out far enough and that one out far enough to where those, because the compounded error here doesn't get impacted. To avoid that, it makes most sense to use those two. Okay? So I'm going to cross multiply. Hit C, sine of 43.1 equals to 186.2 sine 22.72. Divide both sides by sine 43.1. Okay, so I'm just going to write that C is equal to that thing right there. Now, what is nice about this, and this is something that you guys can, the more you do these, always after the first one, you're probably not going to remember this or draw this connection real quick. But look at that, those two things that I put a box around. What's the only thing that's different about them? So again? Yeah, the argument. What is the angle in the sine function? One of them is 71.08, that angle C that I found initially, and the other one is that angle C a second time. Okay, so if you want to maybe shorten your amount of work and maybe not have to write all of this stuff down, if you can make that relationship there kind of permanent to you, you can use that. I'm going to go back up to this, and really now I can just type in like 22.72 here. Okay, or if I really wanted to be creative here, I could take 90 minus C. Nope, that's not right. Not 90. What we had be 180 minus 43.1 minus C. That's not working the way I want it to. Oh. Yeah. It'd be 180 minus 180 minus C minus 43.1. That's still not it. Huh. Just trying to get that 22.72 out of this stuff here. Maybe I got some things. Yeah, that's what I want. Regardless, 22.72. There's you could, because the way I define things up here, you could eliminate all the rounding error that you want to if you're thoughtful about how you need to input this 22.72. Okay. Anybody have questions on this? That kind of makes sense. So now, if I were to give you these three parts at the onset, okay, some of you would, on your desk, make a triangle with an angle of 43.1 degrees. So let's put that one in, 43.1. Okay, so that angle there. We had, so now 43.1, the 248.6 needs to be this one here, 248.6, and this one here would be 186.2. Okay, so if I gave you the original information and you set up on your desk this 43.1, that side there and this side here, some of you are going to create this triangle here with a 65.81, right, as an angle right there. Okay, and you find out also that if you do that, That angle up there was 71.1. We had 0.08, okay? And you found distance C right here to be 257.84. That's what we found, right? Okay. Now the rest of you maybe set the triangle up to where it is now that one there. 114 point. Better. It's close enough. Okay. Did we find up here an angle of, we said 22.72. Okay. And our answer is more accurate because there's human error in here. And we said that this distance here was 105 something, right? Okay. So you see at the onset, if I give you just those conditions, you can't tell me whether there's one or none or two. Does that make sense? You just don't know. So you do the work. In the event that the segments are compared to one another so that, try to get back to the original, let's just do this. Let's say that's 5, and then let's say this other one is 8, something like that. Let's go standard view. Do I touch that dotted line now to create a triangle? Does that make sense? So the ambiguous case, there's still angle side to side with these components of 43.185. But if I were to set the law of sines here, what I end up with, okay, and you would draw your pic, you would draw this like you think you do have a triangle. You would say the sine of 43.1 over 5 is equal to the sine of, I'll just say A here, over 8. And when I cross multiply, I'll get A, eventually, I'll get A equals the sine inverse, okay? So when I cross multiply, this is going to be 8 sine of 43.1 all over 5, okay? Now, here's the thing. If we were to do this on our calculator, I'm just going to type in the 8 sine 43.1 divided by 5. What is the problem with that in regards to putting that into the sine inverse function? Anybody know? It's greater than 1, and the sine inverse is only defined on a domain -1 to 1. So when I type it in, it gives me undefined, which would tell me I have 0 triangles that can be made. I open 5-5. It'll be due Friday. You'll read the instruction. It says something like that where you're